This is Vijay Mugati. I am associated with Ask IITians since last 2 years. I am postgraduated from IIT Patna. I have also received silver medal from Electrical Engineering Department of IIT Patna. Here I am going to discuss you about semiconductor devices. Semiconductors are the materials which are different from metals and insulators, and therefore they are widely used in the electronics field. If you take up an example of any electronic devices such as laptop or smartphones, all are these made up of semiconductor materials, and therefore this has become very much important for us to learn and understand semiconductor devices. So therefore I have divided this chapter into many parts. In the first part I will be discussing you about introduction of semiconductor and the energy band diagram. So let us proceed. Okay students, so let's start with the new chapter called Semiconductor Devices. Let me first tell you what are the topics which I will be going to cover in this chapter. So these are the topics which I will be going to cover. First of all, I will start with the introduction of this chapter. After this, I will be discussing about energy band diagram. After this, what are the types of semiconductors which we have, and what are their properties. After this, we will be discussing about Fermi energy level. After completing the Fermi energy level, I will be discussing about mass action law. So there is a law called mass action, right, for the semiconductors. So what is that? I will be telling about you. After completing all this, I will be taking up a PN junction diode. This is basically a semiconductor device. Okay. After completing this, I will be telling you about conduction in metals, how the conduction takes place in metals. After all this, I will be discussing about breakdown in PN junction diode. After this, what is Hall effect? This I will be discussing out, and after completing all this topic, I will be telling or I will be discussing about the few previous year IIT JEE questions of this topic. Okay, so let's start with the introduction of this chapter. So semiconductors, what is semiconductors? So normally we have three types of materials. Either they are conductors, insulators, or the semiconductors. So the semiconductors are the materials whose electrical conductivity lies in between conductors and insulators. So they are neither perfectly conductor nor they are perfectly insulator. So the conductivity lies in between these two. Okay. So there are few examples of the semiconductors. First is the silicon. Okay. Second one is the germanium, and third one is the cadmium sulfate. So these are few examples of semiconductor. And the silicon has the energy band gap of 1.1 electron volt. Now what is energy band gap, or we can say energy gap? So what is this energy gap, energy band gap? All this we will be discussing in the coming slides. Okay, so till then just wait. So next has the germanium. Germanium has the energy band gap of 0.7 electron volt. Cadmium sulfate, it has the energy band gap of 2.4 electron volt. Fine. So we can see from here the germanium has the least energy band gap and the cadmium sulfate has the maximum energy band gap. Okay. Semiconductors. So silicon, if we see, the silicon is the most widely used semiconductor. In almost most of the applications, silicon is used as a semiconductor, and one of the reason is because it can be operated at a very high temperature. Fine. Semiconductors have negative temperature coefficient of resistance. This means that if we increase the temperature, the resistance will decrease. So there is an inverse relationship between the temperature and the resistance for the semiconductor devices. Okay, so the temperature is inversely proportional to the resistance. Okay. Now energy band diagram. What is energy band diagram represents actually? Let's see this. So first of all, let us take the case energy band diagram of insulators and the metals. Okay. So in any energy band diagrams, so in general there are three types of band. One is called as the conduction band, CB. Second one is the forbidden band, and third one is the valence band. So these are the three bands. Now what is conduction band? Conduction band of any material represents the energy, range of energy, okay, for where the electrons lies, and that electrons are freely available. It means they are available for the conduction. So all the electrons available in the conduction band will be available for the electrical conductivity, or will be responsible for the electrical conductivity of that material. Valence band. So in this, no free electrons exist. So we can say they are bonded. So bonded covalent bond, or the bonded pair of electron hole pair are lying in this band. Okay. Third band, which is the in between these two, is called as a forbidden band. So this is the band of energy where no free electrons exist. Okay. And this difference between the lowest energy level of the conduction band and the highest energy level of the valence band is called as the energy band gap, represented by Eg. So this is the energy band gap which I was talking to you about, right? So if we see for insulator, this band gap is very large, right? And if we see for the metal, so in this metal, if we see, there is overlap between the conduction band and the valence band. So this region represents the overlap between the valence band and the conduction band. That means that there are a few or now more number of, we can say, the electrons which are available for the conduction even at the, we can say, at the room temperature, or we can say as at the zero voltage. We are not applying any voltage or any external voltage, electric field or magnetic field, even though there are number of electrons which are available in the conduction band for the conductivity. Therefore we say that the metals are conductor. Conductor means that conductivity is large, right? Now let's take the case of pure semiconductor. So if you see the energy band diagram for semiconductor, pure semiconductor, so in this we see this energy band gap, or we can say the forbidden band, is very small as compared to the insulators. So this band gap is small as compared to insulator, okay, but there exists some band gap. That means we need to provide some external voltage, okay, or the temperature, we can say, right, to bring the electrons, okay, or to free the electrons and bring them to the valence band from the conduction band. So forbidden band gap is small for the semiconductors, and less energy is required for electrons to move from valence band to conduction band. So there is a less amount of energy will be required to move the electrons from the valence band to the conduction band. See, whenever the electrons are available in the conduction band, that means the conductivity will be possible for that material. If there are no any material or no any electrons in the conduction band, that means that material will not be able to conduct. That means there will not be any flow of current in that material, right? So now as we discussed that for any material we are having three band: conduction band, valence band, and the forbidden band, right? So whenever the electrons, okay, whenever we apply an external voltage and whenever the electrons moves from valence band to conduction band, so since the bond has break, right, bond break, and the electrons move from valence band to conduction band, so it will leave a vacant space, okay, or a place in the valence band. So that vacancy is called as a hole. Okay, whenever the electrons move from valence band to conduction band, it leaves a vacancy, and that is called as a hole. So hole remains when electrons leaves the valence band, and holes acts as a positive charge carrier. So since electrons are negative, and it was bonded, okay, and whenever it moves from valence band to conduction band, so it leaves a space in the valence band, and that is called as a hole, and that is treated as a positive charge carrier and named as hole. So we can say for semiconductors we are having two types of charge carrier. One is called as an electron and second one is called as the hole. Electron are negative charge carrier and holes are positive charge carriers. Okay. Now let's solve an example. Okay, and let's check how much we have learned so far. So first example says that the energy gap in a semiconductor. Option A says increases with temperature, does not change with temperature, decreases with temperature, is zero. See, the energy gap in semiconductor, if we talk about the energy gap and that too with the effect with the temperature, so as we said that if we increase the temperature, so more number of bond breakage will be there in the valence band, and so we can say there will be more number of electrons which will be shifting from the valence band to the conduction band. So we can say, right, so that means more number of electrons we will be having in the conduction band, right? So if this temperature will increase, so we can say that effectively the energy band gap, that is the amount of energy which will be required, right, for the conduction will decrease. So we can say that when the temperature increases, this band gap will decrease, right? So because the reason is the temperature increases, the more number of electrons will be available in the valence band for the conduction or for the conductivity of that material. So we can say that the energy gap will be reduced. Fine. Let us take one more example. So for silicon, the energy gap at 300 degree Kelvin is, right? So I think when we started with the introduction of this topic, so I discussed that the silicon has the energy band gap of 1.1 electron volt, okay, and that is at the 300 Kelvin. So for silicon, the energy band gap will be 1.1 electron volt. So the correct answer for this question is option C. So students, in this part we have discussed about semiconductors. Semiconductors are the materials whose conductivity lies in between metals and insulators. We have also seen that the semiconductors have negative temperature coefficient. That means with the increase in the temperature, the resistivity of the semiconductor decreases. We have also seen the energy band diagram of semiconductors, metals and insulators and the difference between all these three. Now in the next part we are going to study types of semiconductors. So stay tuned with us.